Hello everyone, welcome to day 2 of PyCon Sweden 2020. This section we are going to have Kelvin, a data engineer with background in statistics and machine learning, who are now working at Klarna to present us Don't Just Go with the Flow using Airflow. Welcome, Kelvin.
Thank you. Hello and welcome. My name is Kevin and I put the K in Klarna. No, I'm kidding. Sorry for the bad joke. But I work there and hopefully my talk will be better than my jokes. After this talk, I hope you will learn something new about Klarna's ways of working with data and Airflow. If you don't know what Airflow is, or Klarna for that matter, no worries. I will guide you through it briefly so you can follow the whole presentation. But the main focus of this talk is how we work with Airflow. So first, a big thanks to the PyCon group for pulling this all together. Super cool to see this many interesting talks at the lineup. Really appreciate it. So what is Klarna? We are building an ecosystem for shopping where we are mostly known for our pay now, later products. But in essence, we work with a lot of data. So much data that we needed to create a separate department for handling it, the famous data department. Our mission is to distribute data across the company and build amazing tools and frameworks to work with the data. And we're doing pretty good, with users spread out in more or less the whole company. Our users love SQL, probably more than Python, but I think we get along quite good anyways. I have a background from statistics and machine learning, but I slipped into the data path after my studies. I'm doing my 4th year at Klarna, where I worked in various teams within the data department and been part of the journey of moving from an on-premises solution to a more modern data solution hosted in the cloud. I work as a data engineer, where I previously worked with ETL and more hands-on with the data. Today I work in our data process and frameworks team, where we are building tools to automate and enrich our stakeholders' work. They can be analysts, data scientists, engineers, or customer service agents, anything really. If you work with data at Klarna, you're most likely using our products. And Airflow is a central piece in our product offering. But Airflow out of the box would never work for us, which we will soon find out. Besides working, I enjoy watching mediocre Swedish football and Bayern, but I would need more than 25 minutes to talk about that. Instead of mediocre football, we will be talking about high-quality data tools. To some people, data might not sound like the most fun topic in the world. Columns, tables, and rows. That was my view until I met, or I didn't meet him, I read about him, Chris Dancy, which is a cyborg and the world's most connected man. He uses more variables than you would ever think of. Just imagine how much data he's generating in a day. And with all his devices, almost everything he does is generating data somehow. He even puts gadgets on his dogs and records his life by taking a picture every 30 seconds with a GoPro. That is 2,880 images per day. I have no idea what he does with all the data, but I'm sure he has a master plan. But I do know that all the data we produce needs to be stored, processed, and handled in a secure way, while following laws and regulations such as GDPR. I promise you, once you get to know the subject, you'll find this to be quite an interesting field with challenging problems to solve. For instance, would you know how to process these 2,880 images? Or have you ever tried to open an Excel sheet with more than 10 gigabytes? I have a high-end MacBook, but it still starts to sound like a jet plane if I do that. So we need better tools than Excel to work with data. And Airflow is one of the key players in this market. Data engineering is also a market which is growing at a rapid pace, both in terms of technology and from a career perspective. So today I thought I would share a bit on how we work with data at Klarna, and more specifically, how we use and modify Airflow. In this talk, we will see what is Airflow, what problems does it solve, how does it work, and what is it lacking. We'll also see how we work with Airflow, and throughout the session, we will help Chris. And we will see how me and my team modified Airflow to the better and get insight how we work with and solve problems with Airflow, as well as our users. So imagine you had an assignment to help Chris to get insight to all the data he's generating. What would we need to do? We already know Chris likes data to optimize his life. We also know Chris is a man who appreciates quality and speed. Therefore, he wants feedback on his data with high quality several times per day. To help him, we would need to ingest all the data, build pipelines, handle security, and finally provide insights. And this is a lot of work, especially if we need to repeat it every day. But we can manage. A more sane example would be an e-commerce to request something similar. But let's stay at Chris because he's quite awesome. So Airflow is the perfect tool to help Chris. With Airflow, we can programmatically author, schedule, and monitor workflows, meaning we can create an automated job to perform these different kinds of tasks as Chris wants. So instead of having a team working 24/7, we can create a job and let Airflow do the work for us. We only need to define it once and then monitor it. For example, if Chris gadgets runs out of power and stop producing data, we can make sure that we get notified and take action. Let's see an example where we help Chris using Airflow, and we're going to use the standard way of Airflow. So we start with creating a job for one of his variables. I'm going to choose to start with the Lumovac, which obviously is a device to measure his posture. So first we need to check if the device is alive by sending a heartbeat, then process whatever data he's generating, make a dashboard, and inform Chris that we are done with this run. If we would solve this in Airflow, it would look something like this. So if the Lumovac is alive, we continue with the next box, and so on. If it's not, we break, and we as developers receive a notification that something is broken. In Airflow, this is called a DAG, which is a directed acyclic graph, where each node in the DAG is a task, and each task executes a particular type of operation. For instance, we can have one task that runs HTTP calls, 3 that execute SQL, and another one that sends an email. These different type of operations are called Airflow operators, meaning under the hood of every task, there's an Airflow operator which knows how to execute the specific operation. These operators are written in Python. In fact, Airflow itself is written in Python, and the definition of these tags are also written in Python. So these operators and DAGs are a key element of why we would use Airflow, and we will use them a lot and see that we can create custom ones. Remember them for later, where we will learn more about them. But before that, we can look a bit closer on how Airflow's infrastructure looks. So Airflow is an open source project maintained by Apache, and we can simply install it with pip. The main components of Airflow are a metadata database. It keeps tracks of all the DAGs, tasks, their state, schedule, etc. A scheduler, which communicates with the database to orchestrate and execute jobs. We have a web server, which is a Flask application, which gives the UI used for monitoring the DAGs. And the workers, which is the machines needed to run everything. If we would help Chris, we need to define a DAG. and deploy it to Airflow. Using Python, we can define the DAG like this. We need to set some configurations like a DAG name and a schedule when to run. We need to create a DAG object. We need to define tasks and operators. And finally, we instruct in which order these tags should be executed. And then we have a simple dag.py file. The only thing left is to deploy it to Airflow. To make that happen, we will upload our DAG to Airflow. It will be picked up by our database, and our scheduler will trigger the workers and start executing it. And then the web server will see this new state, and we can monitor it, or in this case, Chris can see how it's doing. And this is how it will look like in Airflow. We can see that we have these 5 tasks in that our DAG is scheduled to run several times per day and going to be executed in this particular order. By now, I hope Chris is very happy because we have helped him in a very sophisticated way. So we have 1 DAG, 5 tasks, and 3 different operators. Okay, so far so good. We've seen what Airflow is. We've seen what the DAG can look like both in code and in Airflow. We know the important components of the infrastructure. We have also learned some different concepts of Airflow, like a DAG consists of tasks which execute different operators, different operation using operators. So time goes by, and Chris is so happy about the work we have done. In fact, he's so happy, so he wants us to do something similar, but now for all his gadgets, and join all the data to one dashboard. And this should just take 5 minutes. 1 eternity later. It took a bit longer, but eventually we would have a DAG which looked like this. And the code for this DAG would be something like this. Something like it. I did a bit of copy-paste, but you get the point. And if you imagine coding this without any coffee in your system, think of how easy it would be to introduce bugs and errors. It's quite amazing that we could pull that off. So let's go grab that cup of coffee. But suddenly, a group of 5 cyborgs appears, and they all want the same dashboards as Chris got. I'm not even going to try to code that, but we would have to turn back around and just forget about that coffee. But for the record, the DAG would look something like this. I think you get the point. That would just be too much work. By now, I think we start to understand that Airflow might not be super convenient for every case. Already here, we can identify some flaws. It seems to become an issue to scale even after just a few complex DAGs. It will be time-consuming to maintain, and we can easily introduce bugs. So let's pause the story of Chris for a while and instead put this in a Klarna context. We have 2,000 DAGs with many tasks. It is used by 1/3 of all the Klarna's teams. We have users with a variation of experience from junior to more senior developers. We are a fast-paced company that is growing in a rapid pace and need to be able to execute different kind of operations. And our Airflow environment is used in production, which means that we cannot have any downtime. That is a lot of responsibility for a single team, and this would be impossible to do by working the vanilla Airflow way. It would crash within a second. Not only do we need to provide a tool to easily create DAGs, we also need to keep up on how Airflow, Python, and the infrastructure evolves. I think my team have created a pretty great product and can handle these problems in a good way. By using our approach, we can turn Chris and the cyborg gang to happy customers. So what have we done? We have separated our Airflow in 3 different key components. Airflow, which consists of Airflow and our infrastructure to run it. We have a DAG file generator application that will help us creating DAGs, and a way for our users to deploy DAGs, but also deployment for Airflow itself. So let's go through them one by one, and in the end we can have a look on how they all fit together. So normally you would just install Airflow with pip install Apache Airflow, and then you're good to go. But we know things evolve, and the next time you do a pip install, it might not work as good for you. For example, Python 3.9 was released a month ago, and Airflow has set a release date for its 2.0 version sometime later this year. So we like new technologies, but we want to keep up with it, but some releases introduce breaking changes. Even small updates to dependent packages might break things for us. So we need to be able to test the things before we start using it. Therefore, we created a Docker image where we specify whichever combination of Airflow and Python we want, as well as all the dependencies. We end up with a library of Docker images to play around with. If you not use Docker, it's just a way you can package your code with dependencies into a deployable unit, so you can reuse it in whatever context you want. I will show an example of this later. And secondly, we need to set up the infrastructure needed to have Airflow running. And this can vary quite a bit depending on your tech stack. But we as a company are heavily invested in AWS, and that explains some of the choices we have made. But I'm sure you can find alternatives to your tech stack. As mentioned earlier, we need somewhere to host our Airflow, a database, and the machines used by the workers. Using Jenkins, Terraform, and Helm charts, we can create scripts that will deploy the whole architecture Airflow runs on. So in our case, we host it in Amazon's Elastic Kubernetes Service, EKS, which is a fully managed Kubernetes service. And as I said, we just create the configuration files and scripts to set up EKS and everything it needs to work properly. And this is true for whatever we need, a database, worker, you name it. All the services and infrastructure we need, we simply put it into configuration files and scripts. In the end, we'll have our infrastructure as code, which we can run when needed with just a click of a button. Fantastic. Another important thing is something we refer to as the DAG store. So typically in Airflow, you deploy your DAGs straight into Airflow. But we don't want our users to fiddle around in the Airflow instance because of security reasons, and they might break other people's DAGs. Actually, it doesn't take that much to break Airflow. One way is just to deploy a DAG with an already existing name, or a more obvious way is to delete files. So we solve this by having our users push the DAG files to an S3 bucket instead, outside of our Airflow, and then we fetch and deploy DAGs by pulling that directory instead. So we will see more about this soon. It might sound like a lot of work to do. So we solve this by creating a CLI to help us. So with this CLI, we can easily create, deploy, and destroy separate Airflow containers in our Kubernetes cluster. So up until now, we have created tools to run any image of Airflow and a way to deploy this to our infrastructure. This enables us to sleep well at night and test updates before they reach production. But let's not forget about Chris and the Cyborg gang. their DAGs still need to be created in an efficient way and be pushed to our DAG store. So before going into details in the DAG file generator, we need to refresh our memory why we need this tool. We know that it can be a hassle to write many and complex workflows, as we saw with the cyborgs. With time, more requests might come, and it can be time-consuming to maintain this. Don't repeat yourself. We don't want to repeat ourselves with skeleton code and do the same mistakes and typos over and over again. Instead, we want to force best practices and reduce skeleton code for our users to write. And we want different operators. Only imagination is the limit of what we can do. So have all of this in mind as we move on to the nitty-gritty of the application. So one way to handle skeleton code is to use a Jinja template, where you replace a placeholder with some input. And we can do this for the simple request from Chris. We insert a name here, input some SQL here, and render it to a DAG file. But it doesn't scale very well. However, we do use Jinja, but maybe not the typical way. This is how our Jinja looks like. Not that much, to be honest. We use it more as a code generation rather than a templating, where we load our modules and then let the submitted DAG configuration files go through our app. And these DAG configurations are something we will get from our users, which we'll soon learn more about. The final output of this Jinja will be the DAG file. So as you might understand, our users will not even be writing these DAGs. We will do it for them. By using this approach, we can scale with quality and easily add new features to the code base. Since we are in full control of the generation of the DAG files, we can validate them and thus never send faulty code to Airflow. Easy things like not having DAGs name the same thing or trying to execute SQL files that doesn't exist. In some cases, we can also unit test and lint the code before they deploy, which can be really handy and save many Benjamins and time. Another important design decision is to not execute the DAGs on our EKS cluster. If we did this, we could potentially have heavy running DAGs eating all the CPUs and memory and bringing down our whole production. Instead, we use these operators to shoot the execution towards other execution engines. In our case, we have a lot of people who want to run SQL on different execution platforms. Some prefer MapReduce on EMR, some prefer Redshift, and some prefer Spark on Glue. And we don't want to be a blocker for what people imagine they want to do. For whatever type of operation they want to execute, we simply set up the infrastructure for it and package it in an operator. So let's pause a bit and let this sink in. We can look at it from a high-level perspective instead. So similar as for the infrastructure part, we use a CLI to instruct the provided input to go through our layers, where we render the code, enrich it, and build the DAGs, which finally gives the DAG file. But how do our users interact with the app? So every user will have their own repository with two mandatory files. A configuration file, which is a YAML, and a CI/CD file, which for us is a Jenkins file. And the rest will just be whatever code they want to execute. So in the configuration file, They define some of the skeleton code, like name, schedule, and owner. They can specify multiple DAGs in one file and define which tasks and operations they want to run. They can also use their own features like, or they can also use features like anchors to reduce code, variables to reduce human errors, and configure special features like custom triggering and ton of features that we have. I will not go through them all, but essentially we can do whatever we want, and we have created some really smart ones. The Jenkins file is configurable, so if you're an experienced user, you can add more steps to it. But in short, it will just use the CLI to render and upload the DAG files to the DAG store. So on every push to Git, you will trigger this pipeline, which renders code into a Python file. Without them knowing, they just written hundreds of lines of Python code without even knowing Python. And that is pretty neat and a great way to create quality DAGs. So to sum it up, from the user's point of view, we've reduced code. In the beginning, we saw that you typically need to write quite much code just to create simple DAGs. And we reduced this by generating the complex DAGs for them with our app. They also need to be experts in both Python and in Airflow, and we kind of reduces that. We let them focus on the actual data modeling and SQL instead, and forget about the whole infrastructure. We enrich them with advanced features and custom operators to run whatever they want. We reduce errors and bugs by validating lint and unit test code before deployment. And for we as developers, we have a Dockerized Airflow where we are able to test new versions before we deploy. We have all our infrastructure as code, which we can deploy with just the click of a button. We can replicate the production environment to try out new features in separate Airflow clusters. And we can create custom operators and execute on any service. And that was what I had today. I want to thank you all for watching, and I want to thank PyCon, my team, and everyone involved. Thank you a lot.
Thank you, Keithan, for such amazing talk. Now is the question and answer section. If audiences have any question, please feel free to comment in the live chat, and we will ask even for that. So now we already have the first question. An audience asks, have you considered using dynamic DAG or DAG generator instead of the Ginger method?
Dynamic DAG in the Ginger template. Was that the question?
I think the audience asked about, like, instead of using Ginger, how about using some dynamic DAG generator?
Oh yeah, now I see the questions. Yeah, I mean, we kind of, I don't really know what's meant by dynamic here, but we kind of do that because we're kind of quite freely allow the users to run whatever they want. But if you would expand the question a bit, I would happy to give a better answer.
Maybe we have left to the audience to ask you via the email. And we have another question. It's about, have you ever pushed the boundaries of your Airflow implementation of latency? So the audience try to give an example saying, deliver increased data in real time itself 7 times a day.
Yeah, I mean, we don't run anything real time. We we schedule everything, but I think that's so how Airflow work is that you need to have a schedule, but you could basically trigger it based on anything you want. So you could have a event-based triggering, but that needs to come outside of Airflow. So if you have, I don't know, new data appearing somewhere, you can trigger your DAG based on that.
Great, thank you. I think this is the end of this talk, since no more questions is coming. The next talk will be at 1:30, so everyone can have a lunch break now.
Nice.
See you all later.
Thank you.
Bye.